Let's take the derivative of this function. This is tricky because we use the chain rule twice. This is a function inside a function inside a function. So we have on the very outside, we have u cubed, and then we have tangent of w, let's say, and then we have 2x, which is w. So this function is inside here, and this function is inside here. So we need to do the chain rule a couple times. So the derivative will be equal to, let's take the derivative of the outer function, which is u cubed. It's 3u, whatever u is, squared. So I took the derivative of 3. The derivative of u to the third is 3u squared. So, and then we leave the inner function unchanged. Well, I'm going to need a little bit more room here. We leave the inner function unchanged. The inner function is the tangent of 2x.
Yeah. So obviously.
So that's the inner function, and then I need to take the derivative of that, the derivative of that, the derivative of tangent 2x. There's a chain rule involved in that. The derivative of tangent is secant squared. So I take the derivative of tangent, which is secant squared, leave the 2x unchanged, but then I multiply that by the derivative of the inner function, the innermost function, which is 2. So let's clean this up a little bit. So this 2 and that 3, really, I can move them both together. 2 times 3 is 6. Tangent, I can write this as tan squared of 2x. Just looks cleaner to write it like that. And then I can write this as secant squared of 2x. Then you always want to just check to make sure there's not something you can do to simplify this further, because you'll notice that these both have the same argument inside there. So I'm thinking in my head, well, a tangent is sine over cosine, and a secant is 1 over cosine, so I can't really cancel those out. But just to be safe, I like to check my trig identities, or the trig formulas or trig identities, and make sure there's nothing that could be simplified. And I don't think you'll find anything for this one, so there's your answer.